Okay, the next two pages that we'll be doing will be comparing data sets and drawing inferences from those. This video should not take near as long as the first one did. Sorry about the length of that one. But what you're going to do with this is you're going to cut on the bold, so you have your title page. You're going to cut this out, and you're going to cut just slits here because these will flip up. These three things will go underneath of each of these, and I'll explain that in just a moment. This gets cut out as a whole, and these flip up. And these things, oh, and then these are where we're going to make some inferences of your own. So once you get a chance, cut those out and then come back and I'll have my page finished. So welcome back if you finally have yours cut out. What I want you to write up here is data sets can be compared by using inferences and measures of center and variability that we just talked about in the last page you should have made. So with that in mind, you're going to have a general inference when you take a look at these. This was a math test scores from first period, the results in second period. So you look at that data and you got to think, what can I make for an inference? Well, a general inference might be second period has fewer students because I could have went up and said 3 students, 6 students, and I could have counted how many students in there, and I would have found out that second period does not have near as much bar graph, but if I added that all up, I'd find out they do have less people. But that has nothing to do with the center or the variability. It just, I have less people. So that's just a general inference. That goes underneath there. Measures of center, we're looking for things in the center here. And this kind of goes off to the side. So a good measure of center would be second period has more students score above the mean. So if you think about the mean being in the middle, this is on the top half of the mean. If you think about the mean in the middle here, you're kind of even. More symmetrical than this one. So a measure of center would say, looks like people did really well in the class, for the most part. A measure of variability inference could be 1/6 of each class scored between 70 and 80. So you can see that between 70 and 80, they were pretty common. Those two are pretty common. This is a little bit different, a little bit different. About the same. You could also made a measure of variability there that between 80 and 90, most of the class in both of them did as well. So measure of variability is anything that you're noticing as differences in between ranges. So variability has to do with the ranges. You want to compare different ones like that. You could compare their one here saying they had more low ones than we did, but remember the class size was smaller too, so taking something with a bigger chunk in it matters. So you come down here, this is just a stem and leaf plot instead of a bar graph. And all you're supposed to do is take a look at it. Like this is 400, and this is 401, 402, 403. This is 421, 421, 423, 427. And so this is the science class, and this is the social studies class. And so what you can make for a general inference, you have to decide what you want to make as a general inference when you take a look at this, what you want to make as a measure of center or a measure of variability. What I'm kind of noticing as I quickly look at this is that these go from 40 to 50, and this starts at a higher rate to begin with. There is no overlap. There is no overlap in this, and there's words in a chapter. So it looks like the social studies is way heavier on words than the science. So that would be my general inference, is that there's more words. Then the measures of center, I don't know what I would say. I'm thinking about where the center is, like in the middle here. And this is only between 10 points, and this is only between 10 points. So the centers are pretty evenly dispersed on both of them, it looks like. And as far as variability, I would say that it's very common right there in the middle. So you can make general inferences on this. You can fill these ones out yourself on an inference you can make from just looking at this. Almost anything, if you have a reason to say it, is going to be right. There's not very many wrong answers on comparing, as long as what you say is fact. So that's the comparing data sets. Over here then, we're going to do drawing inferences, and this is what your original page looks like. So you're going to actually cut this out for your title, cut this out as a group, and then all these will flip up. Cut this out and this out, but this has to flip up because this slides underneath. You'll see what I mean in just a moment. Now my book, for some reason, I couldn't get this to fit on there. I don't know if I didn't put that up high enough and up high enough, but I didn't want this to overlap, so I used 2 pages. But this, if you put it down low enough and this up high enough, it should fit all in one spot, but it didn't work very well for me. So drawing inferences here, you're going to put data sets can be used to make inferences about the group that the data is taken from. So here it looks like there's a practice test scores. And we had 2 people score between 60 and 70. We had 4 people score between 70 and 80, 3 between 80 and 90, and 5 between 90 and 100. So we can make some inferences back here. So number 1, the inference is 3 students scored between 80 and 90. So that's one thing you can say right off the bat. There are 14 students in the class because you can add 2 and 4 is 6, 9, and 5 is 14. So that's what I can get from the data also. 50% of the class scored between 70 and 90. So if I know there's 14 in the class and 70 and 90, right here I have 4 and 3 is 7. So 50% of the class is right there in the middle. Not on the high, not on the low, right there in the middle. The 2 lines are in the middle. Another thing you could have come up with is about 86% of the class scored above 70. So you can also say you didn't have very many fail. Only 2 people did not do well on it. And 60 to 70 is still a D for us, so really nobody failed on this one, which is kind of cool. So on these, you're going to try to make 3 inferences. I did not do these yet because I want you to come up with 3 inferences. And mostly, if you look at it and make a true fact, it's an inference that you can make. So what's this is goals scored in the game. What do you know about the goals scored in the game? Can you come up with any facts based on this that you can infer about it? Like how many goals total were in the game? Were there more goals in the 2 to 3 column? How many games scored only 2 to 3? How many only got 0 or 1? So anything like that. These are going to be heights of 7th graders. Think of 3 inferences you can make there. So inferences can't be wrong as long as they're based on fact. They're based on something within the chart that you see. So I'm letting you have an open-ended area for me to check to see if you actually do it. So that will be where your points come from, is actually making inferences. Okay, so good luck on those 2.